Alright guys, ready to listen?
Alright, I'm listening.
I guess the real people's ready to listen too. Alright, so
Apparently the thing's got like 16 seconds on there.
16 seconds.
16 seconds.
So pretty much, actually you want to be a clicker? Dylan, you want to click it while I do this?
Oh, okay.
Alright, go to the next one. So this is
I
wiring.
think the longer the video goes, the faster it goes. To be honest.
Very smart.
That's not good.
Yeah, go ahead. So we're gonna talk about wiring best practices, and the whole point of doing this is we're talking about why is good wiring important, and I'll show you guys how everything works. So in terms of like the power modules, all the good stuff, and talk about planning. You know, like before you put in all that random stuff in there, I want to make sure you guys know what you guys are
Go,
doing.
okay, this is gonna be
Yeah, so like the thing about planning is it's all about like, so see how you guys have Lexan on your parts, right? So this helps you kind of like have a layout. So like for this, before I did this, is I planned where to put it first, right? So alright, let's go to the next one, and I'm gonna talk about the tools, kind of like what JT was messing with earlier, right? Oh, where did we go?
There we go. You get to it.
So now, why is good wiring important? First thing is safety, because we are messing with wires, with electricity, so
dead.
you could get shocked. It's not too bad, but
It's
you
not.
can get shocked. So, I mean, unless
Makes you feel
unless
awake.
you guys like getting shocked, right? So like the reason why we were talking about safety is because
Safety's number
if
one
you don't
priority.
have, you always want to make sure your batteries are always like have good insulations on it, which means like there's no wires coming out. So like if you guys see like your batteries that has like wires coming out of it, let me know. Or if you guys know what to do, just cover it up with tape, right? Because you make sure that all the batteries that we have, just like if you don't, they can burst into flames or explode. So that's no good. The reason why good wiring is important is robot reliability, right? Like if you guys know your Nano's robot, if you know, like maybe half of the time it didn't work was because of wiring, like the USB connections. So this year, these are gonna be much easier to use. So hopefully your robot should be much better this year. Also easier troubleshooting. Like going back to the Nanos, right? All your wires are inside, so it's really hard to reach. So the reason why good wiring is important is you want to make sure that you place everything kind of where it's reachable. Because like the harder it is to like fix it, then the harder for you to like
Win.
build your robot. Yeah, pretty much. And that's just jokes for the programmers. Oh, programmers can say it's a wire problem. Because programmers always say, "Oh, it's not me. It's the people that wired it." That's my best friend right there. Here's
Best
another
friend
one.
on a different team.
On a different team. So this is the what are we on? 2018, 2017? I gotta change that later. But this is the wiring diagram. So reasons why I gave you guys two phones, right? For all the new guys, like Jacob, or just Jacob, I guess.
Yeah.
So the way it works is you have a driver station. That's why it's a DS, driver station. And then where's my clicker? You have
I'm
one
sorry,
job.
I am trying to multitask.
One job.
Everything.
Hey, you want me to do it?
Okay.
My jobs.
You do the arrow.
Wait. Hey, get off.
So you get. Oh, go back. Go back.
Get off the phone.
Go this way. Press the So this is right. So it's Wi-Fi. Everybody knows Wi-Fi, right?
Wi-Fi, Wi-Fi.
Free Wi-Fi,
Free Wi-Fi.
right? So the way they communicate, if you see, is they use Wi-Fi.
Yeah.
It's called Wi-Fi Direct.
It's called Wi-Fi Direct.
Instead of having like where you all connect to one Wi-Fi access point.
What's
do
the
whatever.
router in here?
This
The
is-
router.
I don't
So
think we
these
have
phones create their own signal and connect to each other.
So like Jacob, imagine this is your Wi-Fi router at home. I mean, it's not, but just imagine. Yeah. So like.
This is
Right. Now the way it works is instead of the phone connecting to the router, it connects to another phone. That's what's called Wi-Fi there.
And so, but instead of like a Wi-Fi hotspot like device, it
They're all-
is
instead
very
of
for
all
just
them
transferring
going
data
to
between
one-
the two.
Is that the same as like
They all
peer-to-peer,
go to each other.
peer-to-peer network? That same
Yeah.
concept?
I think you misspelled it wrong. That's right. It's a capital L in the league.
Oh.
I don't think I did a capital L, but
Oh, okay.
I don't
So
know.
could
Maybe
just-
I did by like not even thinking about it. But
Okay.
Okay.
So this is your driver station. So your driver station again. Your driver station will have, so you got 2 joysticks in there, right? So that's the one whenever you guys are gonna compete, that's the one that stays with you. Because that's the one where the joysticks get connected. So you got 2 joysticks, you got a driver, and you have an operator, right? And then it gets connected to the driver
Driver
station.
control.
And you guys already know this, so like I'm just gonna go skim through it really fast.
Example.
Yes, go to the next one. Well, oh my god, okay.
What?
Driver. No, no, no.
Jacob.
The arrow's not
I said it's all in one.
The arrow's no more?
They all go.
Oh god.
That's actually a really good example.
So it's like
Like,
can you do mirror display instead of like?
Yeah. Let's do it.
Alright, it's not realistic. We're trying to learn.
oh, your page is unresponsive.
There we go.
No.
It's
nice.
from them
Oh,
banging up there.
God.
Just get it, just get it.
Kill it.
So
Oh,
man, so you know, all of this page.
let's go off snap.
Just blame it on the roof, guys.
Guys, I'm making us unable to learn.
Okay.
I mean, I already know
Okay,
stuff,
so-
but, like,
Yeah, but you need a refresher. Because you're gonna be as smart as you can be, but if you don't know the basics, then
computer's not dying because it's already gone
Yeah.
down by half the battery percent.
okay.
Percent now.
Why are you pointing over there?
Go all the way to the wiring diagram.
It's like it's pointing like
Nice.
down the road. The camera's already watching the thing. Yeah.
Reload, reload.
Reload.
Technical difficulty keys.
There's actually a team name type of
Well, I mean, then they must not be very good.
They're really good.
Oh, they are.
Yeah.
They're insane. Oh
Thanks,
wait,
Daddy.
it's
Alright, so
karma.
while this is loading, pretty much all of you guys know, everybody know what this is, other than Jacob, right?
Yeah, I broke that one.
Yeah, so if you guys see, JT signed this one because he broke it. So the biggest thing, right, make sure whenever you guys plug in components other than motors, make sure you guys have the right polarity.
It wasn't my fault.
The right polarity means that you put the black, which is the negative, to the black side, and then the red,
Which is positive.
which is positive, which is on the right side, right? Is this still not working?
Completely crashed.
Alright. So here, I'm gonna go pass that around. So this is the power distribution module. What the power distribution module do? You guys keep listening, right?
Distributes power.
It distributes power, like it said. It distributes power, but it's also a hub of USB connectors. So what that means is what I said. I just found it earlier. Hold on.
We may need to charge that thing while it's recording.
Possibly. So another hub, another example of a hub is this. It's called a legacy module. And the legacy module is it's pretty much it's a hub where it connects. What a hub is, it's just pretty much an extension. Okay, go to the next one.
Two different types of hubs.
Yeah.
There's actually multiple kinds.
The
But
ones we're gonna be working.
the one that we're gonna
And
be
then
working on
there's
is
the
the
RC, which is the robot controller.
So this is your RC, which is like Grant said is the robot controller, right? So from the robot controller, it connects. Whoa! Oh yeah, here.
Two drive.
So imagine, right? You got your driver station here, your other phone. It goes to the robot controller, Wi-Fi there, right? Connects to this, and it connects to the PDM, power distribution module. You got a question?
What were the hubs called? The two different ones?
It's legacy, and the legacy module, and then you'll have the power distribution module.
Okay.
So we have very different types. We have like one for each time. The legacy just allows us to interface with older stuff
So it's called legacy.
before essentially my time.
Modern robotics. Good.
Yeah.
And so from the power distribution module, you can do a lot of things, right? So 2 things to remember about the power distribution module. You guys, listen. So you got data and you got power. That's the 2 things. So power is to power your motors, right? So that allows your motors to rotate. Data, on the other hand, is your inputs and outputs. That's your sensors. That's also your joysticks, right? IOs. So you got two things, right? Remember, power and data. So like,
That was close.
so here, all the Anderson poles, all these are power. But here on the other side, the USBs, the things you guys love so much, is data. So that's what kills your robot most of the time is data. Because that's usually, because power, you can wiggle it as much as you can, it's not gonna do it. It's gonna do much. It's only power. But data, if it gets touched just a little bit and then you lose data, then you lose the signal, right?
And
Because
that's
that's
what
your input
kills
and
the
output.
robots while you're driving them around and they hit each other.
Yep. So let's go to the next side. So
So
everybody
what
get
is the
that?
PDM going? Like,
So the PDM, nice.
Go back.
You said next one.
That's the
What was
wrong-
them signals?
so what are all
The rest? Okay. So all these right here, these are your motor controllers. So where's the power distribution module?
I don't know.
PDM. So again, right? So you got power right here,
Yep.
and then you got USB. Where's the USBs right here? Right. So your USB, that's data. It goes. This is all USB here. The data then goes to your motor controllers. That controls the motors, hence that's why it's called motor controller. You got two types of motor controllers. You got servos, which are these, right? This is your servos. Everybody knows this, right? Servo. And then you got your normal motors, which is just a DC motor controller. Normally when we say it, right, we just call, hey, give me the servo controller. But a servo is also a type of motor. It's just this is called a DC motor, and this is called a servo motor. Get it so far?
So those are the different types of motors.
Yes.
Well, a
So
servo usually
can you guys explain? How about you, Grant? Can you explain what the difference is between this two?
the motor moves faster and it kind of goes in a different direction.
So say DC motor, right? So this is a DC motor. So and then how about the servo?
The servo's mainly meant to like move things in the robot, like if you were to
Like an arm
like an arm, yeah.
or like a gripper? So this is our programmer, so he should know how to
Yeah,
program it.
okay.
So what's the difference?
So, a motor, for example, so DC regular motor, just spins in whatever direction that you send power to it, negative or positive, and will just endlessly spin. Servos can only spin up to like different servos to different degrees.
280 degrees, right?
Can
Right.
be-
Yeah.
I forget.
Yeah, I think it's
There's different ones, but so they only spin up to that, and you can actually, the way they do, notice they have 3 cables going out instead of just 2. You can set a number, basically like a power, that will set it to a certain position. So these have more control, but they're not as strong, and you can't move them as much. These have less control, but they're going to be stronger, and you can move them more.
Yeah, so like he said, right? The motor is really dumb because it only receives power. It doesn't care about data. So it either gets positive volts, which makes it rotate clockwise, or negative volts, which makes it rotate the other way. Right? Everybody gets that so far? But these, on the other hand, these are servos, so these are a little bit smarter because you send them signal and then it's only at specific degrees. So yes.
The reason that we didn't use any of this?
We're probably gonna put them later. I completely forgot about that. But yeah, because right now I want you guys to focus more on just basic programming. Servos are not that complicated, but it is, I would say, in the advance in terms of programming.
Yeah, I think every time I tried to get servo programming, I have broken servo, so.
All right, so now we're gonna go to the planning
so
side.
there was way more on that diagram.
Oh yes.
Will you get back to that later? Or?
Yeah. So if you guys have any more questions about it, ask me. But the key part on that diagram is your motor controllers, which are these two, and then your sensors too. But the sensors, we got multiple kinds of sensors. Let me go talk real quick about the sensors. So as you guys know, the sensors are used for programming, autonomous, right? But we also use it for teleoff. So do you guys remember the 408 robot where it automatically stops the ball? Does anybody know that? No? Alright, let me just show you guys the video. I don't know if you guys have even seen this yet.
So do sometimes our robots have more than one PDM, or are we limited to one?
We're limited to one. So this is the robot that you guys see over there. This is 408. This should make you guys upload it. So I'll show you guys the sensor. Alright, we're testing it, right? We got a drivetrain, kind of like where you guys are right now.
I'm striking gold. It just gets better and better and better and I'm turning heads.
We got it.
Walking on the edge. It's only gonna get better. I think you're gonna like what you see.
So right now, this is all no sensors right now, right?
How it feels. I think you're gonna like what
That's a servo, and there's a gyro right there in the middle. That's why I pointed out down. You see what's flashing? I'll show you guys. These are the sensors that we're using, right? These are servos right here. If you guys are not familiar, these are all kinds of sensors. Does anybody know who that guy is? I thought his name was Michael.
Why?
No, it isn't. So that's going. Yeah, it's servos.
Y'all were the
Okay.
best wired robot.
Thank
Yeah, I
you.
can see this.
I want you guys to be better than that, though. So this is a type of sensor. What it is it's a beam. So the only thing it cares about is if there's something on front of it.
Patrick, Ronquo's admin password for installing Gamer Studio updated version. This one.
It's Broncos 3481. All small. Okay, so this is where the programming really helps. I'm gonna show you guys now. So this robot, it doesn't have a hardware stop. If I'm going too fast, stop me too, okay? So guys, watch this, right? So right now there's no stops. The ball just keeps going out. There's no way to stop the ball. So the way we programmed it, so I'm gonna go back. So our problem was we don't know how to stop the balls. It's just gonna keep going, right? So if we don't program it, you have to look at the robot and intake the ball and then see, oh hey, it's in the top. Let me stop it. A really good way to do that, hold your question real quick, is we added a sensor to make sure that every time the balls go up, it's gonna stop automatically. So like, see how I'm hitting the trigger right here, right? So it's actually intaking it. So I'm gonna show you. So watch on this side of the screen. Even though I'm holding the button, it's not intaking it unless the ball really comes out. Right?
So the sensor is like reading at the bottom
It's
to see
reading.
if there's a ball there,
Yeah.
and then it's reading at the top of the intake to stop it when one reaches the top.
So there's two sensors here. So you got a sensor right by the shooter, and you got a sensor right by before it comes out. So the idea there is, if you take this ball out, then if you're holding the toggle, then it's gonna keep going forward. So it really helps your driver. So like let's say you guys are like trying to like intake something, right? So we're using programming to help you control the robot faster. The faster you can control the robot, the easier for you guys to win, right? Make sense? Alright. Okay, so that's pretty much it. That's it. What's your question, Jacob?
You said sensors are used for what was
Sensors? So sensors are used for programming.
it?
Autonomous, that's what it's called.
Autonomous and more complex layouts.
The ultimate goal is we want to make sure KISS, right? How do you say KISS again? Keep it simple.
Keep it stupid simple.
Keep it simple. I was gonna say it the other way. But that's the same thing with wiring, right? Like the Nano's wiring it's simple, but it's really hard to reach. You want to make sure that when you're wiring something, it has to be like reachable. So like this, like if I have to like swap out a motor hub, or like if I need to like check the wires, it's easily I can take it out and wire it, right? So you want to keep your wiring always easy to access. That's another way of saying KISS, right? Make sure that it's not too complicated, so that when it breaks down, you guys can fix it as soon as possible. All right. I know. So I explained. So I'll talk briefly, right? So we got PDM, power distribution module. It goes to, these are servo controllers, and these are your DC motor controllers. Those are the two kinds. Controls the motors, right? And then you also have these. This is called the
Servo control.
no. There are device interface modules. These are for
servos,
sensors.
right? Oh, I thought it was
So those are for this. Where is it? It's in the front. Oh, it's right. These are your sensors. These are different kinds.
There's like light sensors.
What a sensor is it's just an input. It's just inputs. It's like your joysticks. So does everybody get what I mean by inputs and outputs? Like the difference between the two? So like, let me explain. An input is what you're reading, what goes in, and your output is what goes out. So then let's say right now, I'm gonna throw this Sharpie to JT, right? So JT is receiving an input, right? I throw it at him, and then he'll have a logic. He's gonna think about it, what he's gonna do. His output is he's either gonna cry or he's gonna throw it back at me.
Or
Make
I'm just
sense?
gonna smack out of the
catch
way.
it.
Right? Or he won't do anything, I don't know. I mean, depends on
Hey,
his
let's
logic.
see. Let's find out.
So,
Let's
but
find out what happens.
does that make sense? Inputs and outputs. Okay, so this is a type of an input. Pass it around, GT. So this is a touch button, right? So we use sensors to receive as inputs. That's what those are for. And this is a different kind. That's an ultrasonic that measures distance, which are really nice.
I
for
like
targeting
this.
them.
This is mine. Can I have it?
Oh, it's like your
Another
yes, but
fidget.
those actually work. Those are like $40.
It just went off.
So what kind of sensors are there?
Whenever they hit
Nice.
a thing too hard.
Nice.
It's whenever they hit it too hard.
So we got touch sensors. We got
Here's a part of
ultrasonic
It's so
sensors. We also have color sensors.
Okay, hold on. So ultrasonic are for distance.
Yes.
To like measure.
It measures your
Proximity?
distance. Yeah, if you guys wanna listen, right? So ultrasonic. So the really important sensors that we use, or like Dylan tried to use last year, is ultrasonic, which measure your distance. That's really important because like if your robot's about to crash to the wall,
It can
you
stop
want
it.
you want to make sure that you know the distance before it hits, right? If it's too close to the wall, then it'll stop. You also have proximity sensors, which is like the optical distance, kind of like the one I showed you in the picture earlier. So let's say this fidget spinner is if this is a proximity sensor, and then it's like so right now it's on, right now it's off, right now it's on, right now it's off. So it only checks for proximity. If it's close enough, then it'll turn on. Thank you.
Okay. And then color.
And your color
Hey, Patrick.
checks, like I guess helps.
It reads
I really
color
like that YI
by
camera.
blasting, well, at least with Lego ones, they blast with 3 different colors.
I
red,
really like
green,
that
blue,
YI camera. Where'd you get it?
and will
The Yi.
see what, and will read what comes
Yeah.
back,
Got it
and
online.
then
Really good.
by
Yeah, this one.
I like it.
then it will, for example, since each color has different number, has 3 different numbers based off the RGB spectrum, it will give that number so you can detect, like, for example, if any, like, red in a
Who's
rain.
colorblind? Are you colorblind? And you're colorblind too. Yeah.
Very
so-
minor. Mine's barely.
got me.
almost nothing.
Okay. So what else? So we have color. We have ultrasonics, proximity, color.
We also have gyroscopes. Does anybody know what a gyroscope is?
Yes.
No.
There's balance.
Does anybody know what a hoverboard is?
Yes.
Yes.
Everybody knows.
So a hoverboard has a gyroscope on it. The only reason a hoverboard works is it knows its angle. So gyros measure your angle. So like let's say on the hoverboard, if I move forward, the hoverboard is gonna try to balance itself because that's what gyroscopes are for. So the gyros detects your angle, and then if it knows that it's leaning too much down, then on the programming on the hoverboard, it tries to move it back out.
Another good example is on your phones. Any phone that has an automatic rotation.
Oh yeah, like when you guys are playing
has
games.
a gyro. If it like rotates, it's detecting that your phone all of a sudden is horizontal by sensing a gyroscope.
Or
The
Like-
gyroscope will change.
Or it's like how on the new update, if you go like that, it'll turn on.
So what would be the purpose in a game for a gyroscope?
I'll show you.
Like if you have an angle that you need to park, it can
Yeah,
measure
like-
that you're on the right
Well,
spot.
turning,
Yeah.
turning, like how far you turn turns more.
It's
Yeah.
mainly for autonomous, like turning exact angles or something like that, I guess.
Yeah, so like for us,
What you see,
where is it?
I think you're gonna like how it feels.
So for us,
I think you're gonna like what you see.
normally if you want to use a gyro,
I think
you want to put it in the middle of the robot. So for me, it's kind of blurry right now, but that's our gyro right there, right in the middle. Because if you're like, let's say this is a robot, right? If you put your gyro right here and then you're turning, then your turn is really way off. So you want to put your gyro right in the middle so that it knows the angle, right? There's a way to calibrate it, but if you are gonna put a gyro in your robot, put it in the middle as much as possible.
Okay.
So,
So are there other sensors?
let's see. Can you think of any other?
So wait, which one's it?
Yeah, we already talked about the touch sensor, right?
Yeah.
Touch, ultrasonic color.
A
Touch is just a button.
Yes.
right?
So it's
On,
just
off.
the button. Like I guess.
So it said here, I don't
Grant's favorite button. So I use this. So let's say you have an arm. So you put an arm on your robot, right? So if your arm is a DC motor, which is only it's a stupid motor, right? It only has power. It's only positive or
It'll
negative.
go back up.
So because you can't stop it because it doesn't have any inputs.
Is it stays open until it hits something and then closes and
Listen, I have
Nope,
been
it's just
stop it.
yeah. So we use it to stop it because there's no way because power is not data, right? Power is only an output. So we use an input. So let's say you have an arm, right? And then it's going down, and it's about to hit like this thing. Or like let's say in your robot, like you have an arm, and then if it doesn't know where it's going and it hits this, you can overload the motor. So the way we stop that is we use a sensor. So like a touch sensor would work. So once you hit it, then it kills the motor.
maybe an ultrasonic sensor, maybe.
Ultrasonic, it's just ultrasonic would be a little bit too, like it's too much, right?
Well, if
You want-
it's
you want-
just trying to stop it at like
It's-
a wall.
yeah.
If you are trying to stop it a distance away, that's when you
Same
use
thing, right?
ultrasonic. It's just not as for sure.
It's just overkill.
Like beacons.
Yes. Beacons are.
I had the
horrible.
right code. That was meant to drive.
Okay,
We
Is
so
also
that
have
it?
that's pretty much it. We also have IRs.
IR, which
Why
should
is
don't
never-
you try? Why don't you try and use the code on this thing? Maybe we can
An IR, that was because there's a beacon on
Yeah,
the
we got IR
field,
beacons.
right? And then it's reading the beacon. So when we had to shoot the tall,
So
or it was on the Cascade, whatever,
Effect.
and it the,
Yeah,
the
it's
position
actually
of that
event.
central piece moved. So
Yeah,
the
that-
IR would tell you could read the IRs to know where to go to hit that.
Does anybody know what IR is? Infrared.
Yes.
So
I use it on my remote.
well, like, do you guys know what it is?
Yeah.
What is it?
It's like it bounces
Connecting.
off.
It's kind of like connecting to another.
It's a different kind of light,
Yeah, that's
but we
what I'm
can't
saying.
see it, right? It's not visible light. It's a different kind of wavelength of light.
Infra.
But
There's
That's
long
how-
story short, it's just a different. It's just a light.
It's a light. There's different forms of light that the human eye cannot visualize.
Yeah.
Like ultraviolet.
And
So-
radiation.
So you would only use that if there's an IR beacon on the field somewhere in the
Yeah,
game.
yeah.
somewhere.
Like the only way that IR would work is if there's another IR somewhere else. So you have a receiver and you have a transmitter.
Like, what if your other team has an IR? Then
Then maybe
Unless
yeah,
you're
then you
feeding
guys
them
can
balls or
communicate.
something, but you're not always
Batman
paired
and
up with
Robin.
them, so it doesn't matter.
Batman and
Do you have
Robin.
any more questions?
Oh, yeah.
Jacob,
Batman
Darren,
and
or
Robin
Wookie?
bot.
Yes. Are you over there? Okay.
Okay.
All good? Okay.
Alright, good.
Let's go to the next. Yeah, the crash thing. I want to go back to the
Oh, I
first
thought
thing.
you were about to say.
It crashed again.
So just type in Patrick Angeles. Let's see, yeah, there you go.
No, my phone. I got you.
You're not posting this stuff anywhere, are you?
No.
Okay.
It's only for like Riley and Dylan Watson.
Okay.
Or like, it'll be unlisted in the future as well. That's probably
Okay.
Why?
Because you're selling passwords on it.
Oh, yeah.
I just don't want that out.
Hey,
Yeah.
I mean, if we're gonna upload it, we can bleep them out. Edit it.
Okay, just as long as that's done though.
Is it still recording?
Yes.
Still recording.
Sensors.
So it's like an old version of the device interface.
Yes.
So
Yeah.
older
But the
sensor
thing
model.
is, it actually it's
Yes.
that. But the thing about this is not just sensors. These are actually you can connect all the old stuff in it. So like you can connect motor controllers in it too.
Okay.
So these are your pretty much your inputs and outputs.
Okay. Alright.
So
Thank you, because that's how my brain works. Is like a linear.
So do we start?
Thank you.
yeah, so like does everybody can
Get it?
hold on, let's see. I want to make sure. How about you, Wookie? Can you explain me how the robot wiring works now? So yeah, let's start with the battery. So the actually let's start with the robot driver station.
But Gandhi!
It completely restarted.
Yeah, it crashed down.
There you go, keep it here.
Restore page.
And then show me.
Press restore page.
I wish I could.
I like how the fifth thing is Pretty Little Liars.
Nope.
What?
No, like on the whenever you're typing in
Keep
PR.
going.
Wait, why is there something called Trump bot?
Oh, because it's trying to build a wall. That was our project. That was our summer project last year, but we never finished.
Yeah. Wasn't it Omnibot? Or...
No, that was before Omnibot.
Oh, okay.
So yeah, it would have been nice. It was gonna use the blocks. So the whole idea was it's gonna like stack the blocks
And slowly
then
get higher and higher. Y'all could have built it like this tall
it
and
would have
like
been pretty cool. All right, maximize the screen and we can explain it. Start with why is the screen like no quality.
yeah, like start with like
That
the
right
quality.
there.
Okay, there we go.
There we go.
All right, so what is this?
The robot controller. Use the driver station.
They connect to the driver station, right? And then so going through here, these are all outputs, right? Or this is inputs and outputs. So explain to me this. Go ahead.
I know. Good, there was the put it down. Put up on the distribution model. Okay.
Module, yep.
So that pretty much connects to everything else.
So tell me, so like, where does the battery go?
The battery.
Yep. So it goes. So that's what powers the power distribution module, right? And then from there, what else connects to the PDM? Yep, the core device. We already used it, so yeah.
what?
Yep.
Andrew's
And then how about these? What are these?
unnucleated.
Motor controllers, right? Yep, that's just power, mainly just power, right? And these are called DC. So we got two types of DC motor machines. Right? So these are called DC motors. So that's your DC motor controller, and then the other one is what? That's your. So these are. Wait, let's go. Right here. Great, servo controller. Alright, so that's pretty much it, right? So
Alright,
like,
so can we start?
yes, you guys can start, but hold on.
Looking for a cable?
We're gonna use legacy modules to make it harder for you guys.
What?
Legacy modules. You guys can use this. Alright, so just a recap, right? The way the robot works is you got a battery. Where's the battery? There's no battery. You got a battery, plugs it in here, it goes to the power distribution module, and right by the battery is where the robot controller is connected to. Right, that's your phone. And then from there, you got power, and then you got data. Right, your phone is your data, your battery is your power. Yes. Either Velcro, or if you really wanna work hard, you can use screws.
Usually screw.
But for what we're gonna do, we don't want to waste Velcro, so we're probably gonna go make holes on it. I mean, it really doesn't matter. Or like you can Velcro it on if you want. It's just I'd rather just make holes and then not waste the Velcro. So
Wait, so we're not using PDMs?
no, you guys are not using PDMs. You guys are just gonna use.
We're gonna be using NGX.
You guys are just gonna use legacy modems.
Just regular ends.
Oh, this is just a hub, remember?
Oh.
So, the USB here, the only thing that the USB does here on this thing is just a hub. But because we're only plugging in one
How
thing,
is it going to interface with the phone?
huh?
How is it going to interface with the phone?
It's over here.
That can be correct.
So this detects your legacy. Everything we're gonna use is legacy. So everything should work easy. Make sense?
Yes.
You
Okay.
guys
I
see?
didn't know. I thought those were just like motor controllers.
I know.
for the interface.
Mind blown, right?
Yes.
So this is pretty much what we're gonna use. It's the same thing as
But I
this.
already know how to use that.
Exactly. But I want you guys to learn more. So
But we won't be using that when we're making our
this will be
actual
yours.
robots.
And I think there's Mr. Pronouns, there's a legacy module right there behind you.
I
That
know
box.
I know why you don't want to see the video. We don't have enough.
We don't have enough, and you might break it. That's probably why. So there should be.
I'll show myself.
And GT. Jacob already got one. And there you go.
I need a drill.
You need a drill.
Does Grant have one?
No,
Holes.
Grant doesn't have
And you know I like drills.
one. Okay. And wait, we can have one. You don't have one? Oh, okay, perfect. All right.
We don't have one for Andrew if
Yeah.
he shows
If
up.
Andrew
Because
shows
that's
up,
it.
then he'll probably gonna use medium.
Okay, because that's it on here.
Why does
Okay.
Andrew use medium?
What are we?
So,
What are we?
what? So these are their legacy stuff. So, all the legacy stuff is all the black stuff on the back. So, right. So the first thing, remember, right? We got a plan, right? So you're gonna know how many motors or how many of these do you need. So if you have the way this works, or right now we're not gonna use the servos, so don't worry about the servos. We're gonna use the motor controllers. So if you look, you have motor 1 and motor 2. So one motor controller can only hold 2 motors. So if you have Grant, which has 4 motors, then you have to use 2 motor controllers.
And
But if
then
you
another one for each. I'm going to get a drill.
possibly yes. But if you only have 2 motors, then just 1 motor controller. Simple enough? Make sense?
So, is this 6 motor control?
Yes, possibly. Or you can put sensors. And we're probably gonna put sensors later to make your robots a little bit smarter.
Okay.
Because right now all your robots are really dumb
Like how
because
many?
it doesn't have any sensors on it. As much as we can.
That's me. Okay. I have this, which needs to be with 2 sensors.
So go ahead and grab these. They are in the back, legacy controllers. So right now you guys need motor controllers for robots.
These?
Yes. Done? You don't have a motor controller. Alright. Now you need one more.
How many?
So you guys should know how many you guys need, right?
I have.
So go.
Gotta drill one.
You need one, right? There
Wait.
you go. So one
It's
motor
not a
controller, 2
program?
motors.
So he needs to, right?
He needs to, yes.
You said that this.
I need
6 motor controllers. You can plug in 6 motor controllers.
Yes.
Grant?
Yes, that's yours.
Yes. Why do I need another one?
And then JT?
These things are 2 different things.
They're the same.
Nope, nope, nope. They're not the same. Did you not listen to my class?
I did.
So
Maybe you're starting to feel guilty.
there's one thing for the Andersons. I want to teach you guys how to do it. JT already knows, so like, you don't have to listen to JT.
I don't. Sweet.
Because, but
I don't listen
these
to those.
these are what we use for everything.
Using Anderson. Using.
You're using Andersons for the motor.
Using
Uh,
legacy.
Yes, but on the motor side, where are
You still want to kind of know how to put Andersons and stuff on it, but
that's pretty much
it's gonna be all robotic science.
50% of what you guys are going to be doing next year is Anderson.
Sweet. Already.
So that one needs to be done.
I know, but like I don't need to because this is for my motor, right? I put it in
Yes,
this.
but I want you guys to put Anderson on.
And then cut it off again.
No.
Wait,
I want you to put Anderson to this thing because for next year, this is what we're going to use.
I know, but I mean like for our things right now.
I know.
Don't we need it like this?
Yes. But
But I don't need to practice.
No. You still need to practice. Everybody needs
Fine,
practice.
I'll do one.
So, guys, hold on. So this is a normal wire, right here. This is what comes out. So we gotta put Anderson on these things,
You know, end up looking like that.
and it's gonna end up look like this. Right. This is the goal. So, and then from here, you're gonna have another Anderson's like this, right? It connects, and then it should be stripped like this so that you can plug it on the battery. You guys get it so far? Okay, so I want to explain you guys the way the Anderson works.
Can we stack these?
Yeah.
Ah.
So like this, see this right here? I mean, it's not the same. I tried doing that a long time ago, but it got really ugly. Yeah, I'm gonna keep going on the presentation real quick if you guys wanna follow. GTI, go ahead and take a seat.
I just want to I'm Miss American.
So, guys, watch this. Grant. So the way I do wiring, I try to make the wires. So like if you guys see this right here, these are the temperature channel, right? You guys see, JRM2. I usually try to put the wires under. So like, Grant, for your robot, whenever I do wiring, I usually try to like put them on the corners, or I try to hide them. Because the goal with wiring is, if you think like inside your house, do you guys see like a bunch of wires all over the place?
No.
Not really, right? So the idea is you want to hide it as much as you can. Because the goal is you wire that robot and you should never touch it again. That's the ultimate goal, right? Like you only do it one time and you don't have to worry about it.
There we go.
My dad, he works, I believe that his dad works for a homes. And he usually likes to take us to houses that are not finished yet.
Oh, that's not finished?
Uh-huh.
And you guys can see all the wires?
Sometimes.
Wait, you have a brother here? Oh yeah, okay. Yep. I think forgot it. So yeah, so like that's the same thing, right? Like if you guys like, if you look at that robot, right? Like the 408 robot, I want you guys to like try to make it as neat as possible. I don't wanna stress it too much in this one because we're practicing. Because I mean I want you guys to actually like make mistakes. I'd rather have you guys make mistakes now than in the season, right? Because like on the season, if you guys make mistakes, then it's gonna take longer for us to build and longest for us to have a chance to win too, right? So I'm gonna go to, okay, so this is another example. This is back when I was a student in 2013. And another thing you guys want to make sure whenever you guys are wiring is you want to make sure that your wires are away from the gears or from the motors. So like away from all the moving parts. So like this robot right here, right? You don't want your wires, like, I don't know how you're gonna wire it, but the last thing I want to see on your wiring is you plugging it in here. Oh,
Thanks.
you're welcome. The last thing I want you to see is have your like wire right here, and then like it goes like that. Like make sure your wires are away from the wheels as much as possible. We've had a couple instances where people wired so close, and next thing you know, the gears tore up the wires. Because you want to make sure it's away from moving parts. That goes with servos, that goes with arms.
Can you pick up the legacy?
Oh, yes, I could. Why not? I'm a nice guy.
After dumping it all.
Yes, there you go. See, now I can call myself a nice guy.
Now.
Okay, so this is FRC, right? I don't know if you guys know this robot, but this is the robot nobody talks about because it was so bad. Because we try to do so many things all at once. So this is the robot before the wiring. Oh, they got a little bit of wiring. This is our power distribution module, and this is the wiring afterwards.
Jeez.
So it was so like if you think about it,
just like,
we're like, hey, go find the motor control is not working. It probably takes us like 30 minutes to try to figure it out because it's that bad. So you want to make sure your wiring doesn't look like this. This is actually my wiring. But yeah, it was pretty nasty. And oh, so like this is more for programming. This is called like Brain Map. I don't know if you guys know about the app, but this helps a lot. Like let's say you have like too many stuff going on, right? You always wanna make sure you like kind of like do a wiring diagram for yourself, because like the more you remember like how much stuff you need, the easier for you to troubleshoot, the easier for you to wire in the end. Right. So I want you guys to make sure you guys always plan. So, and that's Alright, so now we're gonna go over the tools. This is what I really want to talk about. Okay, so these are the Andersons. So the way the Anderson works is it has.
I was putting one on right there.
Thank you. And can you give me the black piece too? So, right here, these are called contacts. Contacts are
They're
the
annoying.
reason that they're called contacts is they contact the metal on the Anderson pole. They're metal, right? They're metal contacts. That's what they're called. If you go to like electrical engineering, this is what they're gonna be called. They're called contacts because of metal. Because this is what the wire connects to the power pole. So like, if you look right, I don't know if you guys can all see it, right? There's the metal contact right there. So whenever you connect the other one, it goes like this, and that's, or like actually like this, and that's how they touch, right? So you want to make sure that you have good connectivity. So the biggest issue people have with this thing is getting them in the
I
contact.
know, that's what I'm trying to do right
So like right now, JT is having a problem, but so I want you guys to know how it works. If you guys know how it works, then it's easier for you guys to figure out what's going on. So, this thing. So this is your case right here. So your metal part is right here. So you always want to know the orientation. So see can you guys see the metal right there in the bottom of it? So you want to make sure when you're doing it, you want to make sure that the metal part is in the bottom all the time. And the way this is, it's a hook. See the contact? It goes like this and it goes like that, right? Make sense? So the way it works is there's a line right here that blocks the contact. That's what holds the whole thing. That's what locks it down. You got one? And so the way you have to do it, if you're gonna put in the hook, you need to make sure that when you put it in, it goes in like this, right? So you have to do that movement because there's a blockade right there. So there's that, and that's what locks it in place. Does that make sense to everybody? So I want you guys to try this real quick.
It makes it easier to use the screwdriver.
So is this the one that you did?
I just did it.
Okay. Nice. Wow. All right, now you do it.
Nice cut.
Here. When you put it in
So-
the contacts. Can I start wiring them?
Yeah, you can start.
Shouldn't I like take the wire,
The plastic off?
Yes. So, do we have any more words?
Yeah, over there. Trust me, it's nice.
Yeah. So, alright. So like, you wanna cut your wire. So yeah, I'll
Put it a
show
little
you.
long, and sometimes when I do it, I fold it over. Just the 30 inch.
So actually,
Wait,
Yeah.
I use the
Does it
30
just go
because
over
it makes
plastic?
it easier.
what's up?
Just go over plastic.
Yeah.
You
So
strip the
like,
plastic off.
so these are there's different sizes, right? So like the one that we use is usually the one all the way to the top. And to know how much you have to strip out, it's that length right there. You want your wires to be. You don't want it. I mean, you can have it over, but you normally the amount you need to strip out is just right there.
So I did a good about size.
Yeah, you had it
Left.
pretty good. So I'm gonna go strip the wire, right?
Yeah, I think more sure.
Yes. Go check the FRC side.
First.
So now I pull one out, right, and then I'm gonna spin it to make it nice. And I'm gonna use a 15 amp contact. And then the way it works,
Good thing has small hands.
nice. Yeah, it's good to be small. So now that I stripped the wire, right, I stick it in the contact, and then is this thing broken? Yep, it's broken. So then you stick it in here. So make sure it's in the flat side, right? And then you stick it there. And then so this is another technique. Before you crimp it, especially if you're this is your first time, I stick it on the 15 amp and then hold it, and then now it's crimped. So make sure your wires holds, right? Make sure it's hold. It's not loose. And then you stick it on this thing. Oh, that was broken. Oh, there you go.
And what is the plastic piece called?
They're the
Coat.
they're the Anderson power.
Connector.
Yeah. Yeah, it's the power pole. That's what it's called.
Power pole.
Yeah. You got the
Oh,
contact
okay.
and then you got the power pole.
So which way does it go in? Like
So
up or hook?
hook down, but you need to look at your you need to look at this first, okay?
Settle down.
Perfect. And then now you bring it down, and then you use this and try to shove it in there.
Wait, so Patrick.
This is seriously, you gotta be patient with wiring because it gets really annoying, especially if you don't know how it works. So I think that's why not a lot of people like wiring is because it's just it gets too messy. But once you guys get enough practice, you guys should be good to go. So
I think it looks fun.
it is fun until you start crying at night.
Because it's too
Because like sometimes I'm here at like 11 o'clock at night
Trying to wire.
trying to wire. What? What's up?
How long should the oil like just?
Oh, for these?
How long should I strip it to put it in?
So do it.
Wait, do I have to like unscrew that?
Yeah. That's how
Where
it
do I-
works.
Where do I find
Right
such
there.
small?
Just that much. I could like this one. Hey, what up?
Oh, no one's there.
Oh.
Should I go see what they, because he's checking twice. Should I see what he wants?
Yeah, have we been in my bag.
Maybe he's
Where
checking
do
if
I
there are
find
people
flathead
there.
screwdriver?
You're probably like,
That's
why is
small.
like random for shouting? Did it work?
Where do I find
Did you need to
flathead?
come in, or did you want to come in here?
It's not like
Yes.
Did you need to work?
Oh,
here?
yeah. This one's no good. So you already got wire inside.
Yeah, I
So
don't-
that's good.
We always have stuff all over the carpet. I don't
What
have it.
sort of question?
We're in here all week.
Yeah,
We have a
like that,
competition
like that.
on Friday, so we're here all week.
So actually, so like for the rest, like Jaren, if you guys want to start mounting your wire or your electronics
Okay.
down,
Yeah, we're just
so
in here.
that you guys are doing something. Because I want to make sure you guys are doing something.
Yeah,
So
this
you
is
guys know.
not.
Okay.
So right now you need the next end piece too, right? So go make your next end piece, right? And let's go start with that. And then Dylan or if you guys want to start mounting your electronics to the robot, and then I'm gonna go one by one and then help you guys with that.
No.
I'm gonna give you the right tool because that's really not the right tool that we use. Go crimp the other one, Grant. Go crimp the black one.
So how much?
Patrick, where do I
Yes.
find a flathead screwdriver? That's small.
So start planning.
Ah.
Thanks.
Hold on. It's still recording.
You said that the 30 makes it easier.
Yeah, 30 in.
It's like that.
Put it in the 15 when you're clamping it down.
So
though.
we probably want to talk them up here. We have more support.